Great. Thank you so much, Heiner. It's nice to be with you all today. This presentation pulls from some enhanced rock weathering desk research that's been led by my colleague Yifan Powers, who I'm guessing many of you have had the pleasure of interacting with so far in some of our outreach. This also pulls from the work of PXD's former CEO Owen Barter and his work on innovative financing mechanisms, including being instrumental in establishing the first advanced market commitment for vaccines. So I will try to do justice to some of the work that my colleagues have led. Taking a step back, hopefully most of you on this call are quite familiar with how enhanced rock weathering works, but for those of you who are newer to this topic, in a nutshell, what happens in the ERW process is we have finely ground rocks that are applied to soils, and this drives a chemical weathering reaction, which captures atmospheric carbon and converts it into stable, dissolved forms, which can flow through groundwater into oceans and stay for thousands of years. So the key to this is that ERW is considered a permanent carbon removal strategy. So unlike other land-based strategies like agroforestry, ERW does not require kind of continued implementation to ensure the carbon drawdown. So that's one great benefit. And then another piece worth noting, particularly for this group, is that ERW is particularly attractive as a carbon drawdown strategy for equator and near equator geographies, where there's ideal soil pH, temperature, moisture conditions for this technology. And the PXD's analysis in looking at costs shows that it's over 3 times cheaper to operationalize ERW in Global South versus Global North contexts. Next slide, please. So in terms of some of the desk research that we have done, really the scientific research is still quite nascent in terms of the published studies that are available. Studies use a wide range of materials, application rates, soil types, measurement techniques to estimate the impact of ERW on both carbon capture and in terms of looking at the benefits to farmers. There's a very wide range of estimates on these benefits depending on the study in question, but we can say broadly speaking that in terms of climate benefits on a per acre basis, there can be up to 100 tons of carbon dioxide removed through ERW practices. And in aggregate, thinking about global implementation, we could have up to between 1.7 and 8.5 gigatons of carbon dioxide removed per year if, theoretically speaking, ERW was deployed across all cropland in low and middle income countries. So that's a huge potential that we see. In terms of the impact on farmers, there's very few experiments that have actually tested crop yield effects. Of course, we know about Flux's study that we're looking forward to hearing about from Sam later. But really in terms of looking at kind of a wider range of large sample studies with causal impacts for yields, it's still pretty limited, and particularly in Global South settings. So some studies have shown improvements to soil pH, nutrient retention, and kind of resistance to other stresses. But this is really kind of one of our calls to action that we have for the research community in terms of driving further investment in scientific research studies to be able to quantify the benefits of ERW. Next slide, please. So just kind of a few of the challenges, as I mentioned, we need more scientific research on ERW, particularly in Global South countries. We know MRV at the field level is definitely a key barrier, and I'm looking forward to hearing about some of those experiences from the other speakers, and also developing industry standards for key operational decisions. These are things that the sector needs to address. In some of our recent work, next slide, please, we have looked at really looking at the main challenges in catalyzing ERW in the way that projects are financed. Really, investment in ERW is driven by the private sector through voluntary carbon markets. And as private sector firms focusing on necessary recovery of investments and maintaining a competitive edge, it's challenging to sufficiently invest in kind of the broader research and development necessary to implement ERW at a global scale, particularly in Global South countries. So in terms of being able to realize the potential of ERW at the scale required for notable carbon drawdown. There's lots of market inefficiencies that we have identified, which has led to these financing gaps. So looking at slow field learning, given that firms are competing to gain market access to recover their investment. Most of the investment currently is skewed towards high-income countries. As I mentioned, there's a lack of common standards and also some lacking attention to some of the broader public objectives that can be achieved through ERW. Next slide, please. So our solution hypothesis that we've put forth in a recent paper that was circulated to this group before this call is really something that we developed through engagements with a wide range of stakeholders, many of you on this call, and participation of our advisory group members. So really our view is that without some sort of additional incentive, the level of private investment in ERW will be far lower than is merited by the potential benefits to society for both climate and poverty alleviation benefits. So we think it's essential to develop financing mechanisms that can unlock the full potential of ERW as a public good. So what we have proposed to the world is developing a diverse market commitment to help coordinate objectives from various outcome funders so that we can properly value both the public benefits in terms of climate, food systems, and scientific capacity building, and the private benefits that can accrue to farmers and communities for agricultural productivity and income, and make sure that these are properly valued and invested in by both funders who are interested in achieving, as I said, both climate and poverty alleviation aims. So this idea builds on a well-established concept of advanced market commitments, which has been used for vaccines. It's a financing mechanism that can create market incentives for firms to invest in needed but underexplored technologies and to invest in making it more widely available. So our approach that we are proposing blends kind of these resources from different funders to help incentivize distributionally equitable carbon dioxide removal through ERW. So there's lots of details in our paper, but I wanted to kind of just throw that out there to this group and looking forward to getting some of your feedback. Next slide. I just wanted to kind of mention a few of the recommendations that we have that can perhaps generate some discussion today. Really, as I said, filling in the research gaps about ERW's impacts on farmers in the Global South, both agronomic and income. This is going to be one of the essential precursors to developing financing mechanisms to really catalyze ERW at scale. And also looking at establishing best practices and benefit sharing and operational models for ERW projects in the Global South. So I will leave it there for now. PXD remains very excited about ERW's potential for carbon removal and for smallholder farmers to benefit. So lots of research and financing gaps to fill, but looking forward to today's discussion and learning from others' work today.
Super. Thank you so much, Caitlin. This was on the time side on the longer end. We don't have time for questions right now, so we'll just move on straightly to Shantanu, if that works. If you please go ahead and talk about multi-carbon and introduce yourself quickly.
Thank you, Einar, and very interesting presentation, Caitlin. Thank you for that. Some of the recommendations are things which we're already doing, so I'm very delighted to be presenting Marty Carbon's work in smallholder farmer climate adaptation, specifically with enhanced shock weathering. If you can go to the next slide, please. So click, please. So just click through it. Yes, please. So Marty Carbon is probably one of the first ones who started out working with enhanced rock weathering in the Global South. Technology originally was founded on the base of the Yale University work, and all the research was in the US, but we started working and trying to get the technology which was developed through the Illinois trials and the Arkansas trials and Louisiana trials for us to move to India and try to work in the smallholder setting, which was quite interesting for us to really adapt the MRV, which turns out that every new agroecology zone is a challenge on its own. It can't really just be a copy-paste MRV. So we learned that for firsthand when we tried to develop that for India about 3 years ago. And since then, we have really been able to, I would say the MRV for India is close to complete for us. and it's now ready for scaling, which we're doing in India. Mati's India's development, India's deployments were also the first ones to deliver engineered CDR certificates to a customer in terms of credits delivered for the first time in from any country in the global south, and also was a first for enhanced rock weathering as well. And we continue to deliver carbon credits from our deployments in 2022 and 2023. And now we're scaling to a significant extent. We've got more than 8,000 farmers working with us and more than 6,000 acres of farmland, which is under our work. And we're scaling in India and establishing new MRVs with the work in Zambia and Tanzania. And actually, I'm calling to you right now from a field location in Tanzania where I got delayed. So I'm sitting in a car right now going back to the hotel to some civilization. But we have also got a bunch of research going on where we have continuously run trials in agriculture research settings where we are trying to figure out a lot of data around how the MRV has to be adapted, how the MRV has to be developed, and also the benefits of doing this farming at in these various agroecology zones and meteorological conditions. We also have large-scale data of farmer benefit now with more than 1,000 farmers actually measured with control and sort of field application measurements on both the productivity and the CDR, which we've done over the past. So all this data is now being converted to some papers, which we'll publish. We've also published some papers in the past. We'll continue to publish them. We try to get as much data out there to the public as possible. Also, lastly, but not the least, we entirely focus on smallholder farmers. Typical farm size for our more than 8,000 farmers is 3 acres. And I think we have cracked the challenge, which was initially laid out to us initially, was that we shouldn't really go after small.
Hello, Shantanu?
Yeah. Because it's going to be very tough to really manage the heterogeneity and also manage the challenges of. Hello? Hello?
Yeah, we
Hello,
can
can you
hear
guys
you
hear
now.
me?
Yeah, keep going.
Oh, I'm sorry. Where did I drop
Just
off?
keep
Sorry about
going.
We
that.
lost you
I
for
was
a
just
couple
saying,
of seconds,
yeah.
but please carry on.
Okay, so yeah, so I was just saying that we feel that we have cracked the way to handle a very sophisticated, high-tech scientific method and try to sort of build out that robust engineered MRV method and deliver that to a place where you typically don't get internet, like the internet problems we're having right now, and doing work with very small parcels of lands and pretty rustic settings where farmers don't understand what we're doing. But we have been able to sort of build the systems and the technology stack to do that. We go to the next slide, please. Next slide, please. Yeah. Just click through it, please. So as I said, we have become proficient in dealing with smallholder farming. We've got a proprietary MRV and a technology stack to deal with that. We've also got a continuous learning method, which we've developed for adapting the MRV for the various settings and agroecology zones, which we have to deal with. And we're now developing almost a customized method to really go after any new agro zone, which we have to go after, and sort of we've built up a scaling methodology for that. And I think the whole bottom line is to really figure out a way to reduce cost to develop these MRV systems for these agro zones across the global south and build a carbon credit price range or cost, which is low enough for this to scale so that this can benefit the amount of benefit which is out there to be grabbed at, which Caitlin talked about in her presentation earlier. Next slide, please. Just click through it, please. Yeah, so some of the challenges which we have is obviously the biggest one, which smallholder farmers, when you go to a smallholder farmer in a new region who hasn't heard of enhanced rock weathering, and you're trying to give it away for free like we are, and we are doing it everything, basically spreading in their fields, they are very suspicious. So farmer perception, acceptance, and sort of transfer of that trust is a very important piece for us. We try to figure that out with partnerships and sort of joining up with local NGOs who already have that trust relationship with the farmers. And that's what we've done successfully now in multiple countries, and we hope that we can carry that over. But that trust relationship is very critical to really get indoors into any kind of new farmer relationship. And then the results speak for themselves after a couple of seasons. The farmer themselves start really accepting it and wanting it. And that's what we've seen now in India, where we have no shortage of farmers. We've got farmers sort of banging through our door wanting this materials because they've seen the benefits of it. But in new zones, it's a real challenge to get that bridge to the farmer acceptance. The other one is the market acceptance. I think ERW, MRV is still in infancy. A lot of customers are not educated enough on ERW and do not treat it the same way they treat DAC. The value and the sort of open system MRV is not given the same credit it needs to be given. And we're trying to change that with the highly sophisticated MRV, which we have developed, and we continue to sort of improve upon it. But there's a journey to be had there. Next slide, please. Just click through it, please. And I think the last slide for us is we are here to share our experiences. We extensively publish and we'll continue to publish our learnings for the general world to really learn from. And we're also very happy to partner with organizations who want to work with us in new regions and help us scale this across. We are also a nonprofit controlled entity. We are not funded by venture capital or private equity. We're entirely focused on the farmer benefit. And so for us to really share our MRV with a new organization is not a problem. We're happy to work with new organizations to help scale this in new regions. And our mission is the farmer, not really profit taking here. So look forward to collaborations and working with folks who are on this call and hoping to scale MRV and ERW. Thank you.
Super, Shantanu, that was a really interesting. Thank you, and for doing it in the car as well. Also, I don't think we have time right now for questions, so we're moving on, and we are going to Egypt. Vickert, please.
I'm not now. You can hear me, all right?
Yes.
Okay. Yes, I'll take you to Egypt. So that is Global South, if you wish, where we have started a enhanced rock weathering test, really in the Libyan desert. So no rain, no humidity, and everything you do has to be irrigated. So when we started, we said, what do we want to do? We want to show how effective it is if you add basalt powder to the rock. So in other words, the effectiveness of the sequestration. How much fertilizer do you get from it for plants to grow? And what is the role of the microbiome? Personally, I'm convinced that the microbiome is the engine for the entire process. And then contribute to the carbon credit system. And I'm happy to hear from Shantanu that he is already doing this. Next slide, please. So this is the land where we're working, and this is really desert land. The blue ring is 20 hectares, so the central pivot irrigated land. We use a quarter of this. At the start, it's just pure sand, nothing in there, no carbon, no microbes, nothing. And so no clay minerals, it's just 87% quartz. So because the soil is so bad, we had to add 47 tons per hectare per season to make plants, give them some chance to grow. And we mix into that compost basalt in different mixes. And then we truck that out over this ring-like constructed field. This is purely for operational reasons. So we have, I see that the numbers have shifted a bit, but okay. So relatively to compost, 27% carbon basalt here and 5 there. In the topsoil, we add about 0.98% in the topsoil of basalt, or 0.1 in the different rings. Next slide, please. This is our process. We buy the basalt 30 kilometers away from a quarry. We grind it to 26 microns. 80% of all grains are smaller than 40 microns. Mix that with the compost. Why do we do that? We do that before spreading it out because we want the basalt to intimately connect to the microbial world of the compost before we spread it out. Also, it reduces the dust problem. If you just use a disker and spreading it out, it is an enormous dust problem. Here you see from this picture, the picture and the spreading out, that that problem is manageable. On the left-hand side, you see that we had here still 8 test sites, and now we have only 4 for operational reason. We had to reduce it, but this is our process. Next slide, please. Okay, we sample 3 times, just at the start, in the middle, and at the end of the growth season. We do about 12 commingled samples per plot, and then add to that 2 standard spot samples We do that twice, one for microbial analysis, one for soil analysis. So in total, so far we have collected 450 samples for the project, and we look at how the plants grow. So we have a botanist in the team, we have a sill chemist in the team who does the standard soil carbon analysis, and he's also now developing the TICAT published by Tom Lersemius. I'm sure you all have seen that, to assess the mobile cations and hope to get to dissolution rate through that route. And then very importantly, the soil microbial analysis, because as I said, we think this is the engine of the entire process. Next slide, please. It's just because we have so little time, just some quick results. You see the crop yield, 15% improvement. This is for wheat, and you see with basalt is definitely much better than without anything, and so that goes pretty well. That's the nutrient supply, of course, that you look at. In terms of carbon sequestration, we see some buildup of organic carbon, but it's not clear yet what the relationship to the basalt amendment is relatively to the compost amendment. We have to have more samples to do that. And the cation ratio assessment, we're in the middle of developing a solid analytical method that works in our case. In the soil microbiology, there is clear difference between crop type and treatment type. And we also see that specific microbes are dominating the whole process of basalt dissolution. So what are, in our view, the key challenges is in sampling. The soils are so inhomogeneous, so the sampling is really a big problem for signal to noise. This is maybe just private, that we want to do things in an operational setting, like it will be later when you sell your carbon credits. It's an operational setting. So we do our test in an operational setting. That is not easy, I can tell you. And then the cation ratio, where we think we're getting close to having a method that works, but that's still early on. And one of our main headaches is that we really don't know the basalt dissolution, how incongruent or how congruent the dissolution is. And then key question for us is, what is doable, practical, and affordable MRV method? And I'm looking forward to get the information from the previous speaker to start selling ERW to the farming community. I think that's it.
Hey, super. Thank you so much for giving us a line of sight into your work in a desert setting. And I think we will keep going with the flow. This is going really well. And we're going further south, I think, to Kenya. Sam, and can you please take us to Flux?
Thanks very much. Hey guys, great to meet everyone. I'm Sam Davies. I'm the CEO and co-founder at Flux, and we focus on enhanced rock weathering solutions in Africa. We're headquartered in Nairobi, which is where the vast majority of the team sits, alongside some global scientific team members from various universities across the world. Next slide. This is pretty busy, and I know we're short on time, so I'll fly through it. I'm really happy to engage with people after the call. What we've done so far is our main pilot has been a UNCCD-funded trial with smallholder farmers, which was the first time rock weathering was deployed in an actual farm setting in Africa. We worked with 56 farmers, and this is the study that was alluded to earlier, which I was hoping to get published in time for this call, but sadly we've had to make some changes this week. It will be with the wider world next week, and I'm really looking forward to sharing that with you guys, and also thank you to some of the people on the call who have helped contribute to that. But the headline figure is that we saw on average 40% yield increases on maize crop. The trial was a split trial per plot, so we had a control and treatment per farmer. And as alluded to from the last speaker, we wanted to test this in an operational environment with real farms in real settings. And so we learned a lot of lessons there, and I'm super happy to share those with everyone. This year, our big traction on the commercial side has been pre-purchases from Milky Wire and Frontier, and those deployments are going to take place on larger sugarcane farms in Kisumu County in Western Kenya. The farm size will be around 600 hectares of deployment. And alongside those deployments in Kisumu, we are developing a lab and also a sort of research center and office there, which will become a hub. And whilst we work with commercial farms alongside smallholders, we see that that is a fantastic way to build our data sets and understand rock weathering at large scale. And the MRV and the data that we get from that then trickles down into the smallholder farmers. We're also super excited to announce fairly soon that we've just signed an MOU with one of the Cash Coalition partners, One Acre Fund, to run a large-scale smallholder pilot next year, which we're currently looking for funding for, but that will basically expand on the initial work that we've done with the UNCCD and incorporate more soil types and more rock types. On the farmer side, from the success of the initial trial and the work that our agents did in the field, we now have over 2,000 smallholders onboarded on a waiting list for trials in Kisumu County. And we have over 20,000 hectares of commercial farmland that we're ready to deploy on as well. Next slide. What did we learn? We actually had great responses from the smallholders. This is partly because of the situation they're in. Fertilizer is very expensive, so a lot of people don't have any access to inputs. We also figured that with very small farms, hand spreading was much more effective in terms of cost and time than mechanical spreading. So that was a key takeaway and something that we want to expand on and get better data on exactly what happens there. And also the key one is that the agronomic benefits can be really, really big and significant for these farmers. And that's because the areas that we work in, some of the soils are incredibly depleted. We want to keep learning. We need to keep learning. I think as Shantanu highlighted, the key to this is data-driven MRV. So we've got that tech stack in line as well. And the more data and the more deployments that we do, the better those tools will become. I think that's absolutely crucial. We also want to get better at quantifying social impact long term. Next slide. So, sorry, it's just loading. Okay, yeah. So I think one of the key things we want out of the trials in terms of smallholders is bringing down the cost of MRV. That is absolutely key if we want to scale rock weathering. At the moment, there are buyers willing to fund expensive credits up front for now, but these guys are the innovators and they're the outliers in the market. So for rock weathering to truly scale, we have to get the cost down, and a lot of that is going to come down to modeling or other innovative ways to bring down the amount of CO2 you can quantify per sample, because the key unit cost is lab analysis. Next slide. So we're super happy to share all the information from the first trial and everything that we've done. That white paper will be published, as I said, next week. The deployment only happened in February. The results were captured in June and August, so we worked really hard to turn it around as fast as possible, and all the raw data will be available as well. It'll become peer-reviewed and a fully published paper next year, but ultimately we find that that pathway is just too slow right now, and we'll keep doing that with all our deployments. We're really keen always to learn from people who have already operated in these environments. And I'm sure there's a lot of people on this call here who have far more experience with smallholders than we do. And the best thing that we can get is critiques and concerns and diverse opinions on what we're doing, because as with all startups, it's easy to get into a bubble about how great we are, but we also need reminders about the challenges and things that other people come up with. So I'm very thick-skinned. I don't take offense. And I'm really looking forward to getting your feedback, whether it's after this call or another time. Thanks very much. I think that's it.